Hey, it's Blockchain Bernie here with our next episode. Man, 5,000 lines of code. It was supposed to be just a small app, right? And as everything in life, it's more complicated than you think. And, I thought it's like a few hundred lines of code. It turned out to be almost 6,000 lines of code. And about 40% of that is Rust code. The rest is JavaScript code. And I want to let you know in this video what I learned because I hadn't written any other Solana app before. I didn't even know Rust before, right? I love Rust now. It's a really, really great and I've been, like a systems programmer. I like to develop close to the hardware. And it's a lot of fun with Rust, and it's really safe. It prevents, memory leaks and all these things. Absolutely love that. But, Rust is quite a learning curve. But then on top of that, Solana with Solana smart contracts. And when we developed the app at first, I was the one doing the back end, which means the code that actually runs on the Solana blockchain and is being executed by thousands of validators that make up the Solana chain. So that's called the backend. And I was the one doing that in the first release, all of my own. And then I had a team member, Kaveen. Kaveen, you're the best. And he did all the front end, all on his own for our initial version of our app. And the app is called Node Store, and it is basically what it is. We're building a storage layer for Solana. It is its own blockchain, so we need our own validators and stuff like that. And our way to get the financing to develop the blockchain is by selling node licenses. So the blockchain is going to be permissioned. You need a license to run that validator. And the node store is, the store where people can purchase their node licenses. And we thought like, well, that's a simple thing to do in Solana. But, there are so many edge cases, and the Bitoku blockchain is built in a way that, an equal amount of rewards of Oku tokens, and the Oku tokens pay for storage services because Bitoku is the storage blockchain. And we have a fixed number of Oku tokens each and every day that are being generated as rewards, and those are being shared among all node owners. And that makes the code so complicated because nodes are being sold all the time. And when we have launch events, everyone's trying to buy nodes at the same time because they get the best price then, because we have an ascending pricing model, right? So then there's a lot of, motion in there. And then if you buy a node and you share it with 2,371 others, right? But then the next minute, someone else buys a node and you have to share the fixed rewards with one more node, right? And that has to be calculated there. And it all has to be, the records have to be kept on the blockchain, and it has to be low storage, right? Because if you have large data structures, first of all, it costs a lot of money, what's called rent on Solana to store all your data. And it has to be compact because of that, right? So, and that adds complexity. And then there's so many things in Solana that make life complicated, right? Another one is like there is a restriction in the so-called stack size. So whatever you can push onto the stack in that programming model can only be a maximum of 8 kilobytes. But then under the hood, if you use the Anchor framework, which is kind of the beginner's framework, it's supposed to make life easy, but only if you have really small data structures, right? If you have like arrays in there and it's only like 2,000 bytes, it will be blown up internally by the Anchor framework, and it's not documented anywhere, and you get like weird errors. And it took me nights and nights, honestly, and I remember that time to debug that and to figure out, oh, for some reason it has been deserialized by the Anchor framework, and then it blew up the stack, right? So yeah, and then we had to find other ways to do that. So you really feel like a systems programmer on the Solana blockchain to figure all this stuff out. It is kind of fun, but if you're under time pressure and you have a launch coming up, it is really stressful, right? So yeah, that took a lot of time, and you can see here our repos on GitLab, right? The node store, that is all the Rust code with all the smart contracts in there. The node shop is the front end, and that's the node store is close to 2,000 lines of Rust. The node shop is 2,500, 2,800 lines of JavaScript. And then in order to have a tool to see actually what we've stored on the blockchain and how to read it and make sense of it, we made a separate app called Okulytics for internal use. That's also a lot of code. We have the Okubin and Okubin backend. So that's our kind of MVP, minimum viable product, to actually demo the storage utility for our Oku token. Yeah, and lots of other stuff. We have the white paper here, the technical white paper that describes our upcoming Bitoku blockchain. So that's work in progress. Yeah, you see there's a lot of different repos here that we've been working on. And in the end, it was almost 6,000 lines of code, right? And the back end, the actual Solana programs, it was complicated because sometimes it's hard to debug. And then, I mentioned the limitations on the data structure, sizes, and stuff like that. Then also in Solana, each program has to declare, in the beginning, what Solana accounts will be read, what Solana accounts will be written to, what Solana accounts will be signers, so that the signature has to be verified. And that is all because the Solana runtime is designed to be super, super fast, and it's designed to be parallelizable, right? So that means you need to declare all the accounts that are read and written so that they can, execute these things in parallel. That does not happen in Ethereum compatible chains, right? Everything's sequential there, right? Nothing goes in parallel, right? Not so in Solana. It is way, way faster, which is super important because blockchains have to be fast. Otherwise, they can never be mass adopted, right? They have to scale, and without speed and performance, there's no scaling. So it's an awesome feature of Solana, but on the other hand, it puts a lot of pressure on the programmer because that is a new programming model, right? Usually you don't do that. You can just create, data structures as you go in your code. But here, every time you figure out like, oh, I need a new data structure on the blockchain, and it has to be a new Solana account, like with a program derived address. It's those PDAs that are, super important in Solana programming. And it all takes a lot of time, and you create a lot of code. But man, we're proud of that app because that node store is not trivial. It implements that ascending pricing model that I talked about. It implements all the parallelism. If, several people buy nodes at several times and they bid certain prices, it's, when you can pledge an amount to buy nodes, but you can also say, I want this and that many nodes, and then it tells you how much it is. But this can all change really fast. And it's battle proven, right? Even for those launches when we have like hundreds and thousands of purchase transactions per second, it all worked super smoothly, and it's all documented on the blockchain. So that's really cool. And the best thing we have in Node Store is a full-blown affiliate system, right? So anyone that refers other people that then buy nodes, they will get rewarded with 5% extra rewards for 10 years, right? And that's all being recorded in Node Store. and it's 5% for both, right? For the one that refers and also the one that is being referred, right? So it's not not trivial, that code. Let me know in the comments if you want to know more about any specific component of our app or DApp, right? Distributed app. And happy to share a little bit more and show parts of the source code and stuff like that. Just let me know in the comments if you're interested and what parts are you interested in. Otherwise, give this video a thumbs up. Subscribe to my channel. I'm pushing out fresh content 3 times a week, mostly live, but this one's recorded. And thanks for watching, and catch you later.